Hello and welcome to this mini recap video on how to do correlations. So correlations are a form of relationship testing, and when you are examining for relationships between sets of data, you must have two variables that each participant must have a score for on both of those variables. Now, a relationship test or a correlation test is trying to examine the presence of a linear, straight line, essentially relationship, between the scores of those two variables. And it allows us to determine if that relationship is statistically significantly different and or due to chance. And the test also goes some way in helping to determine the amount of variability that one variable can be explained or almost predicted by the other variable. So an easy way to imagine this, for example, could be height and weight. As people get taller, they get heavier, and you could be able to predict one of these variables from that other variable. And one of the steps to doing a correlation test is to produce a scatter plot so that it helps visualize the data. Now, when we do stats testing, I always get people to start with this decision tree, and what we will do is start at the top. So the first question is, what am I trying to measure? And we're going to the left hand side of this decision tree because we're choosing to do relationships with groups. Now, the next step down is, what type of data do I have? And here you can determine whether it's parametric or non-parametric. To determine whether it is parametric or non-parametric, you can first of all have a look at the type of data that you've got, or secondly, conduct normality assessments on your data. So that could be your bell-shaped curve to examine skewness and kurtosis. Remember that if you're using data which is ordinal, so that's data that's ordered, for example, the position of people finish in a race, or Likert scales, because that's on a numbered scale, for example 1, 2, 3, 4 or 5, that is generally considered non-parametric, whereas parametric data would be an example of something like height or weight, because it's scalar quantity. So this is the first step to determining which type of correlation test we need, because you can either have a Pearson correlation if the data is parametric, or you need a Spearman rank order correlation if your data follows these non-parametric characteristics. So I'm going to first of all start with parametric, and here we see the instructions written in blue for how to do a Pearson's correlation. And the correlation that's presented on the slide here is examining height in centimetres versus weight in kilos of participants, and you can see the scatter graph that's drawn. But the table at the top is actually our correlation statistics that we're interested in. So I've circled in red the data that's interesting. We see that our Pearson correlation value is 0.631. So that tells us we've got a pretty good correlation between weight in kilos versus height. Our p-value, written here as sig two-tailed, is 0.000. So this indicates to us that it's highly significant relationship. Now n in this instance just relates to the number of participants that this test or this correlation has been done on. The next correlation is the Spearman's row, and again you see in blue font here and italics as well the instructions that you would need to click on in SPSS to conduct this type of correlation. And on the slide we also see our SPSS output. So we've got our Spearman's row correlation and again I've circled in red the output. So our correlation coefficient for the examination of grip strength versus how would you categorise your fitness status was 0.257. Now, the reason we've done a Spearman's correlation on this is because this data is considered nominal. So nominal is a named category, so people are asked to rate their fitness status on low, medium or high, and then when you correlate that with grip strength, this is the value that we got. Notice we have a slightly different N here of 87. Okay, so here we are in SPSS, and this part of the video is to demonstrate those instructions that are written in blue italic font. So this is how we're going to do a Pearson's correlation. So remember, a Pearson is when you have got parametric data. Now, what I've got on the screen here is an example data set, and the instructions that I give would work for any data set that you've got that fits the same criteria that I'm doing today. So we're going to look at doing our bivariate Pearson correlation on height and weight. So to do that, you first of all click Analyze, and then you come down to Correlate, and then click Bivariate. It's bivariate because it means it's got two pieces of data. So in this instance, height and weight. So we need to move height and weight over into our variable box. You need to double check that Pearson is ticked, and then just make sure as well that you've got two-tailed and flag significant correlations. If all of that is in those boxes, you can then click OK, and that brings up your output window. And what we've got in our output window here is our correlation table, and you'll notice that this correlation table is similar to what's presented on the PowerPoint slide. So we've got our Pearson correlation of 0.631 in our sig two-tailed, giving us our p-value is 0.000. So it's a significant positive relationship. Now the next step is to undertake a scatter plot, or to have a look at that relationship, to actually visualize what's going on. So to do that, again, you click on Graphs. You then come down to Legacy Dialogues and Scatter/Dot. It'll come up with a series of options. You just want a simple scatter, so we're going to click Define, and then you need to make sure that your data is moved over into this Y and X axis box. So I've put in weight under the X axis, Y axis is height, and then we click OK. And notice again in our output diagram, it then draws us a scatter plot. To add a line of best fit to see what's going on with our correlation, you double click the box, and you then click this little line here, or this little button that says Add Fit Line at Total. It'll bring up a new window, but you can close that, and it gives us our line of best fit, if you like, our correlation. Okay, so now on to doing our Spearman correlation. So this is when we do a correlation where some of the data is considered non-parametric. So what we're going to correlate here is fitness status and grip strength. So very similarly to the previous correlation, you come down to Correlate, again bivariate, and it will then bring up the new box. What we want to make sure is that in our variable box we have the variables that we are interested in correlating. So we said that the first one of interest is fitness status. So what you'll need to do is find the variable of interest in your list. And I've got quite a long list here, but here is my fitness status, and I move that across. The next one is grip strength, so I need to find that on my list. Here it is, and move it over. I said we need to do a Spearman, so you tick the Spearman box, remove Pearson, and you should be ready to go. And here we are with our correlation box, our output in SPSS demonstrating our correlation result. Notice our correlation coefficient for grip strength versus how would you categorize your fitness status as 0.257, and our p-value indicated here as sig two-tailed is 0.016. So it's less than our p-value of 0.05, so it's a significant correlation. And we've got 87 individuals that were included in this correlation.